All right, before we were looking at writing and graphing compound inequalities. Right now I want to look at how do we solve these compound inequalities. Before we get into that, there's a couple things that we have to remind ourselves. First of all, what is a compound inequality? It's two inequalities that are working together. And when we're solving inequalities, the one rule that we have to remember is that when we're multiplying or dividing by a negative number, that's when we have to switch the inequality. So here we have the union of two inequalities. 5x plus 12 is greater than 32, or negative 2x plus 7 is greater than or equal to 13. Since we have these two separate inequalities that are working together, we can just solve each of them individually. So on the first one, the 5x plus 12 is greater than 32. We want to get rid of the adding or subtracting first. So I'm going to subtract 12 from both sides. On the left, we're left with 5x. And on the right-hand side, we're left with 20. Then we deal with the multiplying and dividing, so we divide both sides by 5. And since we divided by a positive number, we don't have to worry about switching the inequality, and that will stay x is greater than 4. Now we deal with the other inequality. Same way, I'm going to deal with adding and subtracting first, so I'm going to subtract 7 from both sides. And we're left with negative 2x is greater than or equal to 6. And now we divide both sides by negative 2. Since we divided by a negative number, we do have to switch the inequality, so now it's x is less than or equal to that negative 3. Of course, we also have to bring down this or in order to keep it a compound inequality. Otherwise, it's just two separate inequalities. But all of our solutions are going to be those x's that are greater than 4 or less than or equal to negative 3. So if we're going to graph them, x being greater than 4 puts a circle at 4, and we want all of the numbers that are larger than 4. So my arrow is going to go off to the right. For x is less than or equal to negative 3, at negative 3, we use a dot for the or equals to, and we want all the numbers that are smaller than negative 3. So my arrow is going to go off to the left. Let's try another one. X minus 3 is greater than or equal to negative 8, and 2x is less than 6. And what we should do is, just like before, solve each of these individually. So for the x minus 3 is greater than or equal to negative 8, get rid of minus 3 by adding 3 to both sides. On the left-hand side, we're left with x. On the right-hand side, negative 8 plus 3 is negative 5. For the other inequality, I have 2x is less than or equal to 6. We're going to divide both sides by 2. Cancel that 2, and we're left with x is less than 3. And we bring down the and to see how those two are working together. So when we graph this, what we have is that the x is greater than or equal to negative 5, means put a dot on negative 5 for the equal to. And we're talking about all the numbers that are greater than negative 5. We also want all the numbers that are less than 3. So we're going to put a circle on 3 because it's not equal to 3. And all the numbers that are less than 3. Now, the solutions to this compound inequality are all the numbers that meet both of those conditions. Not one or the other. It's the first one and the second one at the same time. So, of course, that's going to be just these ones that are in between, which means we can go back and erase this part of our arrows because that's not going to be needed at all. If you remember from before, we wrote this compound inequality, this intersection of two inequalities, as a string like this. Since x is greater than negative 5, x would be greater than or equal to negative 5, and x is less than 3. So what if we start out with this compound inequality that looks like a string, where we have 0 is less than 3x minus 9, which is less than 9? Well, what we can do is, just like the last example, break it up into two separate inequalities, where the first one would be 0 is less than 3x minus 9. And the second one is where 3x minus 9 is less than 9. And we can solve each of them that way. Now, why don't I just take a second and do that? We're going to add 9 to both sides. So we'll have 9 is less than 3x divided by 3 on both sides, and x is going to be greater than 3. And we do the other one. Same 2 steps, because it's the same expression that was in the middle. 3x is going to be less than 18, divide by 3, x is less than 6. And of course bring down the and. So we can definitely break it up into 2 separate inequalities like that. But I want to show you a more savvy way to do it as well. That is that if we started with 0 is less than 3x minus 9, which is less than 9. Okay? We can deal with this as an inequality that has 3 sides to it. There's the middle, and the left, and the right. And just like we used to do, our number one rule for solving stuff is whatever we do to one side, we got to do it to the other. It's just now, whatever we do to one side, we do to all 3 sides, the middle, the left, and the right. So I want to get that x alone, and I want that x to be left in the middle. So I'm going to start by adding 9 to get rid of this 9. Since I added 9 to the middle, I also have to add 9 to the left and to the right. Now we have 9 is less than 3x, which is less than 18. We want to get that x alone, so we divide by 3 in the middle. Whatever we do to the middle, we want to do to the left and to the right. So 9 divided by 3 is 3, and 18 divided by 3 is 6. And both of these compound inequalities mean the same thing. They're going to have x being in between that positive 3 and positive 6. And so that's what our graph would look like. But when we treat all 3 sides, treat that compound inequality as one with 3 different sides to it, it really cuts down on the work that we had to do, because if you look in the first side, everything that we did for this first half, we did the exact same thing for the second half. When we treat all 3 sides at the same time, then it kind of cuts down on how many times we have to add 9 and how many times we have to divide by 3.